I was talking unmuted. Hello, how are you doing? Are you coming from the FPS lag? Guess it's time to start. So oh, nice. I guess I should put. Yeah. Been learning TypeScript recently. Nice. What do you work with? JavaScript, or you come from other background, or you are just learning programming? That's also possible. So for today, what I want to do is talk about remote data in TypeScript. But first, I forgot to share the last time. So with some of the other, I got into process in Java, then experimented with Unity, built a few games, got tired of closed source, overwhelmed. I do this all the time. I'm reading and halfway I start just mumbling. I got tired of closed source, big overhead things, and started looking to JavaScript. I realized that it's very type language. Yeah, of course. I started from JavaScript. Well, actually I did like C++, but that doesn't count college. Then PHP and JavaScript. And when I found type languages, I was much better off. Yeah, so I normally do functional programming related things with TypeScript or Haskell or other of the languages, and today I wanted to talk about RemoteData, but first I forgot to share the last time with some of the other SP streamers. We have a Discord. Invite. Yeah, I'm already there, but yeah, we have the Discord channel. Yeah, and you can join chat there in the different channels. Yeah, and there is also, I need to add commands, like other commands to share these things, but there is also a list of SP streamers, like Vlad is there, Chiroptical, some of the people doing Agda and category theory. So that's the list here. I think the one that is missing is Fish, which I forgot his Nation Ultra, and he does stream on the US time zone, but does cool stuff with Haskell. Identity GS. Man, I cannot keep up with all the streamers. Maybe I know them, but yeah, I think I've seen a few of his streams. Cool stuff. Yeah. So Idris. I haven't looked into it. Idris 2 already. So these are all the people that are streaming. Chiroptical is also streaming. Let's follow him as well. Are you still working with Unison? I missed, yeah, I was on holidays for 2 weeks, so I missed everything. How is it going? It was good, yeah. It turns out that the first Airbnb didn't have Wi-Fi for the first week, and the second, and we missed that. So, and there was no data like in the phone for the phone there. It was quite a remote place, so we basically disconnected from everything. And then in the second one, for the second week, we forgot that. Then sorry, no, we didn't forget to check. We actually checked intentionally, but then the Wi-Fi the first day stopped working and they never fixed it. So we were kind of like with no internet. I was planning like to watch all the streams and maybe binge on Netflix, but we ended up just like going out basically because we didn't have it. But actually it was good for holidays. And now they are putting more restrictions again here in Europe, so we might have got kind of like the latest way of holidays. It was also warm back here in Netherlands. Yeah, it's good to back here in Netherlands it's starting to get cold again. So yeah, that's the Discord. I need to remember to share it at the end. So what is RemoteData? First of all, I gave a presentation about it. It's not my idea at all. Yeah, right. But the idea is that to find a better way to model asynchronous operations. So this is something that you can you commonly do in TypeScript, where you have it's loading, it loaded, not used all the time, but can also be useful. And then you have optional data, which can be any key or an optional error. And these are, for example, cases, the valid cases. So you haven't made the request yet, or it's still loading, or the success or failure branches as well. So you do have, like, for example, a user, or you have an error. And this is how you use it in React. So basically the idea is that you use this to model the status. But what happens when you get something weird like this, where it says it's loading and it has the error and the user, for example? It doesn't make sense, but there are no type error here. There is no single source of truth of the data, but it doesn't. It still compiles, and we basically would like to avoid that. So the first, the approach you can take is to solve it is to use, in TypeScript it's union types. In Elm or Haskell or PureScript it will be called algebraic data types, and it will look something like, where is it, like this. So you have type with the error and the data as generics, and then the 4 cases: not ask, loading, failure, and success. And with these, now you don't have more optional values anymore, because the data, when you have a success, is always there, and the error is always there, and the compiler checks this. So you use it pretty much in the same way, but the compilers check. So if you, for example, forget to add the data here, it will give you an error, or if you add an error when you shouldn't, right? And yeah, to make it declarative, because in languages that have pattern matching, like Elm, so let's say we have in Haskell, for example, data, remote data, where we have the error and the error and data. And then this is not asked, or loading, or failure with an error, or success with the data. And then when you use it, if you have a function that, I don't know, checked show message, it takes a remote data of whatever, string as error and number as the success, and it shows returns string. Show message So we have the remote data value, and then case of you pattern match on it. So when it's not asked, you can return a string of it, and yeah, you pattern match on the other cases. So loading, reloading, failure, we ignore the error, the value that it has inside, and we say failure. Actually, failure with the string, so we can concatenate them. And then success has a number for some reason. So yeah, so this is how you use it, right? And this is quite nice, but in TypeScript, if you need to use it like that, it's so annoying, or at least to me. So what you can do is implement like a poor man's pattern matching, where you basically take this pattern matching that is done explicitly with a bunch of if-elses here, and you transform that into a match or a fault. And then this is how the component looks. So this is a bit, if you, what do you say? If you close your eyes, it's similar, like, okay, this is extra, but here we are pattern matching, and it's kind of similar to this. What is it called? Eyes? Not in Dutch, come on. Yeah, if you squint your eyes, kind of looks the same, maybe. Yeah, so that's basically what I want to implement today. And not only that, but all the type classes from FPTS, and I'll get into what that means. So for example, the Elm version, which I think it's the one that made it quite popular, and there is a good article about it, at least in front-end, made this remote data type popular. Implements several cases, some documentation. Here there was a case of pattern matching. So there is a map 2, map 3, unmap. Okay, succeed, map error, map both from task, and then, so these are all things that, because Elm doesn't have type classes, they are just implemented for each type, but in a language with type classes or that mimics them, you will implement the type classes interface. So and how is it going, chat? Any questions until now? I'll keep this for reference. So I did implement remote data a while back, but I wasn't using TypeScript yet. This is like 2 years old. So let's see what is there. Yeah. So this is the implementation, and I want to clean it up quite a bit, like using any instead of unknown, and all the, for example, chain map that are implemented but not as type class. They're just implement. So we probably might want to take the TypeScript version. Yes, that's super. This is super old. Yeah. And yeah, so what is remote data? That is remote data. Let's implement it and then let's see what are type classes. We can implement a few of them because it's also interesting to see how TypeScript, the FPTS library, does the mimicking of type classes in a language that does not have or like support for them. Okay. Okay. Let's start from scratch. So we will have type remote data that it takes the error the data, and it can be either not as loading failure with an error or success data. So now what are those things? Interface as so there has to be like a tag for TypeScript to be able to differentiate between these branches. So this loading. Let's do access with data. Hey, Sunny Pigtails, that's an awesome name. Thank you for the follow. And welcome to the functional programming stuff. I need to give a name. So there will be a data. Okay. And where we have the error. Then there will be an error of type. Right? So now we have our type. Yes, and we this is only checking. Okay, this is only checking. How did you find the stream? Where do you come from? The functional programming Slack, or do you come from just like browsing Twitch? Are you into functional programming, or you don't even know what it is? Which library? This one? I'm surprised. I don't even use it myself because I wrote. FPTS is not my library. So you're probably aware of that, but this PTS is from Giulio Canti, and it's a really cool guy that it's basically put in the whole FP scene of TypeScript in his shoulders, doing all the awesome libraries. There is more stuff now. Mike Arnaldi was in the stream on Tuesday. He's also doing cool stuff with Matex. But yeah, PTS is from Giulio. Okay, maybe I haven't seen you by the same. Nice. Nice to have you then. And if you have any questions, please ask. Okay, so this is the type, and we could basically just work with this. So for example, yeah, we could say that we have interface user and there's something wrong. Let me restart the editor. Okay. And it auto formatted. Didn't want. Okay. Doesn't matter. So we could say fetch user will be this remote data ever and user. This is tag says the data is changed. Yeah, so but then we need, yeah, as I showed, if we want to use it, we do like fetch user. Why does it know that it has data? What if I do string here? This is weird. It should. Let me see. Actually, it shouldn't know because remote data can be any of those. So okay, it knows that this is a success, but what if I do the show message function where we take remote data and then okay, so now here we only know the tag and it can be any of them. So to know that we are in the success, we can check if this is a success, and then TypeScript knows that in this case we do have the data. But this is quite annoying to work with, and defining it like this is also annoying. So let's see. First, so let's define the not asked to be so this is the not asked in the loading. This one, and then to control success construct. Well, this is a function because now we need to construct, we need the data value. So we take key, which can be, which falls to unknown, that would be the data, and we return remote data. Or have to check how BTS does it for the other tag. But then the tag should be a success, and then data. What is wrong here? Ah, it returned. Okay, and then the same is for failure. Where now we had error. Yes. And what's wrong with this now? The error goes here. Okay, so now it's easier to create. By the way, this should be read only because nobody should be accessing these or like modifying them, right? How is it going until now, chat? Any questions? I keep asking chat if it has questions and nobody is asking. Maybe it's just Haskellers that don't understand types. Okay, so now we can create the user that we had today. Touch user be success window, and this is might have to change the neighbors here to unknown because it might be that it doesn't compose well the types, but for now okay. Yeah, let's not move things. So the next things we want to do, and this is where I'll start copying what FPTS does, for example, for either. It implements fold as the way to pattern match. Takes two functions. Either has two types similar to RemoteData, where RemoteData has four. So fold will take a matcher, and the matcher will have a loading which will go from to R. We have a type result, not asked as well. Success would grab the data. So we need the type for the data, and it needs to return R all the time. Every time, so we need the type for the data as well. And failure will have the error, so we need the type for the error. Okay, so this is a function that takes a matcher and then takes a RemoteData with the error and the data, and it returns R. And how to implement this? So we just do the basically the imperative pattern matching. If RT tag is not asked, we then fold not asked matcher. Okay, now TypeScript knows here it cannot be not asked anymore because we already pattern match and return. So then this loading. then is failure, and then in failure we know that we do have an error, and then for the success we have the data. So this means that now we can fold and I removed the example, the Haskell example. I should have kept it, but so we can now dust. Loading, success, failure. So we have the name, right? Name. And in the case of the error, we can do let's say that the error has a message. And this, yeah, now it doesn't know what, so we should pass the types. So okay, we can use error, user error. I should change this. So data comes, error comes first, because it comes first in the definition here as well. Okay, so have the error, have the user, and we return. Because this is show message. Yeah, text remote data with error user returns string, and now we can do show message with our fetch user. And this can be implemented, that can be done for anything. We don't need, it doesn't need to be only remote data. So one thing that I use like this called algebraic data types in other languages or discriminated unions type was like payment methods. So you have different type of payment methods, like your user pays with PayPal or credit card or what else? Yeah, I don't know, another method, and then you pattern match, and then you render like your React component based on what type of payment method the user has, and you know that you're not making any mistakes because your data is like modeled in a way that you cannot make silly errors. And yeah, basically that's remote data. I like to implement this fold thing, and one actually pro tip again is Bibliocantic has let's see, yes, generator, no, it has a generator. No. CodeGen. Why it is CodeGen? I didn't know about that one. So we could, in this CodeGen, we could write, for example, let's use the, yeah, we'll write this here, data, and it basically creates implementation with the fold as well. Let's see the fold that I like. and this is the same thing. We did that he uses a switch, but yeah, so FPTS code. You write basically the Haskell type, and it generates the thing, and it also generates lenses with monocle TS, but that's we are not. He uses never here. Okay, and actually it gets the good type. Okay. But yeah, then you can like paste this and boom, you already have your algebraic data type. Because the thing is, like, this is all you have to write it in Haskell, because these are already the constructors that we implemented here, and the pattern matching, which we implemented with we implemented the constructors here, and the pattern matching that we implemented in default, it's a feature of the language. So yeah, okay, so now for the fun part, let's keeping the examples at the bottom. So now comes type classes. So what are type classes? So type classes provide the theoretical underpinning of FPTS. They describe what you can do with your data, and they're built on laws. That's kind of like, that doesn't say much, but basically type class describes the behavior of some data, and usually there are laws, like mathematical laws. For some type classes you can implement your own, and then you don't have to. I think they come from Haskell. Type classes. No. Okay, but we can think of them as an interface, and then you can put constraints on your data. So for example, this. So for example, you can say, yeah, so we saw that we use show here. Let's show the Haskell repo. So what is the type of show? It's a function that goes from an A to a string, but it's not any A. It's an A that satisfies the show constraint. So it means that it implements the show typed class, and it's something that can be displayed. So if we see the information of show, it tells you that you need to either implement show or show preg, one of these two, to implement the type class. There are many. So for example, what is the type of fmap? So it takes a functor f, and then the f shows up here and here, and there can be many in different ones. So what the type of is, for example, fractionals. So you can use type classes for everything. So basically this is the way you implement constraint polymorphism in Haskell, and FPTS mimics that. So there should be a guide here on writing type classes instances, and you need to do a bit of module augmentation. Yeah, so we'll implement functor first, which is the class that lets you map over things, like an array So yeah, need to do this. I'll copy. And I guess we need to add. Okay. So this is something that I'll explain. So the URI is yeah, in this module FPTS defines a mapping for the kinds, and that's something about the yeah, like registering that you are implementing the type class, and in our case it's called remote data. And then I think it's URI2 kind 2. Yes, where there is an A and data, and this will be remote data with A and right. So in our case, and this is called remote. Okay, so this is just like to register, and this is something that you don't need to do in Haskell because the language implements the dynamic dispatching of the type classes functions, part of the language, where, for example, so one fractional, this is a fractional, right? Where we saw that this needed a fractional, but we could use other fractionals. So how does it know? Okay, the type of 0.5 is fraction. So what was? Okay, it could be either float or double. So how does it know which one to use? That's implemented by Haskell, but we don't have that in TypeScript. And the kind is basically the kind of like the type of type. So for example, remote data kind is start to start to start. What does this mean? So a string, for example, has the kind star because it's just a type. So every type that you can use directly has kind star. Array, on the other hand, you never have an array. You have an array of something. So like array of t. So array is kind start to start. Is like a function where we take one type like string and we return another. So then if we say array of strings, then this becomes, now we just have like one type. So the kind is I'm trying to explain and I'm failing probably. Kind is the type of types, in a sense. So it's this, basically you have values like foo, right? And the type of foo is a string. And then you have types like a string, type foo, which is a string, and the kind of foo is a star. Or yeah. So what does it mean? It's kind of like the types for types, and then what any type that you can just use directly is kind of star. and then you have types that required you to pass higher order types, basically, where you pass another type to it and then they return you a type. So array, for example, a string, you can use it directly, but array, the kind of array is new Haskell naming scheme. Yeah, probably. What's new? Kind star becomes type. Yes. Yes. And yeah. So what's Chiroptical saying? It's better. Give me 1 second. Yeah. So that makes it more clear. Yeah. So the kind of string will be. So this is just a type, right? So string is type. Then array is a function in the type level. Is a function that takes a type and returns you another type. So when you give it a string, it's not a function anymore because you already gave it a type, and now it just becomes a type and you can use it. In the case of remote data, this is type to type because it takes 2 types. It takes the error and the data, and then it gives you type. So if we say remote data with error and user, for example, then this is type because you already applied the 2 types. And I don't know if that made it more confusing. Thank you, Chiroptical, for sharing that. So, and that's kind, and this is how we register kinds types with a kind of 2. And why is it kind of 2? Because it takes 2 types arguments to return you the other type. Okay, and now we can start. If we go back to the guide, we can implement the functor. And we were going to implement functor 2, which is for functors that takes 2 arguments. So here how does it do it? Functor of the URI. Functor 2. Okay, and it tells us what maps needs to be here. So map needs to take a remote data value. It takes the error, the data, and then data, and takes remote data of A, which is as the E and the A. What else? And then takes a function. Okay. So it takes a function that goes from A to B and returns remote data of E of B. So what does basically this means? It takes a remote data that in the success branch has a type A. Whoops. And it returns a remote data that in the success has a B. And the only way we have to go from this type A to the B is with this function here that goes from A to B. So it means that we will do something like remote data of A data, which is of type, should be of type A, F, and then this will be like a success. But we we don't always have the data, so we can use fault here. So in the case of not asked, we just return not asked. In the case of loading, we just return loading, because there is nothing we can do. In the case of failure, we can just do failure applied to the error. So that means we can do a short here. In the case of success, we do have our data, which is of type A, so we can return success of the F of the data. F of data transform. So data is of type, what's wrong? Case not inferring properly, and it might be missing. I'm missing this. What is the type of data? E. So it has E, A, and then it returns remote data of E and B. Yes. So the type of data is A. Type of success. Sorry, the type of data is A. F transform this to a B, and then we return the success of B. And this is the functor implementation. And if we go to use it explains a bit the laws that they need to follow. So the first law, let's copy them and see if we can see something about it. So first law says that mapping of some functor that has an A with an identity function, it's the same as not doing any. And we can't, so that makes sense. So if we have functor that map, and we have, for example, our fetched user, and then we do turn that, this should be the same as just fetched user, because the function here is, sorry, this function here is, it's not doing anything, right? And it's complaining that I used it before defining it. Of course, strict equality doesn't work in JavaScript, but yeah, that's what basically the identity function law is saying. And this we are giving it, and then we can say RD, yeah. And then the composition one, it it's quite interesting as well. So it says that if we have functor that map with the fetched user, and then we have a function that goes from A, and it first does A to B with that A, and then it does B to C with that A. That should be the same as first mapping so first we map with A to B, and then we map with B to C, and those two things should be the same. So what we have here, we transform the write type to a B, from the A to a B, and then from B to C. And in this side, we transform directly the type A to a C. So the result is the same. And these laws basically prevent you from implementing the unexpected kind of functor. For example, what if we an unlawful functor that always returned not asked. Right, so these type checks. But what happens if we give it not asked? We get a not asked back. But if we give it a loading, we get not asked back, and that doesn't pass the identity. So yeah, the composition one, how do I find? So this will, I think this should break the composition one as well. No, not this implementation, but yeah, I cannot come up now with an example that fails the composition. But okay, so what is map used for? So for example, we have a fetch user, and then we have a function that says get name, and it goes from user to the name. So if we do functor that map with our fetch user and with get name, what we get back is the string inside, because this function goes from the user to string, and here we had the user on the left. So we had the user on the left, and the function goes from user to string, so now our functor has the string inside. The same way where you do a write.map, and you have if you do a write.map with get name, you have a list of strings, where first you have a list of users. Right, so yeah, Functor is useful when you have a, if I have a user like I can basically do, yes, I write TS for my shop. I can do this and I get the string. But when I have fetch user, I cannot apply get name. Get name to fetch user. Because it's not type user, the user is inside the remote data and it might not be there. But then with the map you are able to apply, and then on data, right? This is why useful functor is important. We could fault and we could apply the function and wrap it again, basically what the implementation of functor is doing, but that will, yeah, I write to get back to your question, I write TS at work. I've been writing TS for like 3 years, but I recently started using, well, recently, no, at the beginning of this year, I started to slowly introduce FPTS at work. With IOTS, which is kind of like ISON, how do you pronounce it? ISON. Let's see. You should have, yes, additional ones should be want to share. Yes, so I wrote about it. Nice. If you write vanilla, I mean, yeah, it's good to know there are like, it's a pretty big community with TypeScript. Or the JavaScript in general, and almost everything that is in JavaScript you can find the tag types for TypeScript. So there is a lot of code that you can use, but the FP stuff is quite hacky and it's not often used. Okay, so we implemented functor. Now we will implement applicative, which is kind of like the next step, let's say. Applicative, but I think in applicative need to, yeah, we need to, in FPTS we need to implement applied first. Apply to, and this is probably the more mind-bending one of all the type classes. So we do something similar where we say apply, but it needs to implement what? Yes, apply needs to what was I implement? Yeah, apply needs to implement functor and then the AP app. So we can put the functor here and then we do app. What is the type of app? Maybe we can app. Okay, so this is remote data, remote data, remote data, sorry. But you do write Python at work now, right? Technical. So you're more than familiar with imperative stuff. Yeah. Okay, so what does it do? Let's break this down. So it takes again the E, the A, and the B. But the remote data is of AB is a function inside. So remote data, it has the error on the left. It's yeah, I know, I understand that it's a new position. And what did I'm curious if you can share what is it about? Is it pure script, TypeScript on the backend or on the front end? And then Haskell on the backend. Well, I guess if they use Haskell on the backend, that might be open for the FP stuff, or maybe they are already using. Okay, so then we have remote data with the E and the A. Okay, nice. Then it's fun. It's more verbose, basically, and you will fight with type inference a lot more. It can bite you a lot. Okay, so the type signatures looks not so different to map, where we have some remote data of A and A, and we return remote data of A and B. So in that sense, that is the same, but the interesting thing is that the function is, let's call it remote data F, is inside. Now, so how do we handle that? So the function is inside the first value. So what does that mean? Well, it doesn't change the fact that if it's not wait, this is A. Yeah, so, and these three cases stay the same because we don't have anything to play with. But in the case of the success, what we get is a function. We get a function, and this function goes from A to B. And where do we have the A? Well, the A is inside the other remote data. Functor here is like the instance. So we define the functor instance here, but the apply instance, it needs to extend the functor, right? As in Haskell as well. So we either can just like copy paste this here. Yeah, it's building a record, so we can copy paste it here with the map, or we can just spread the other instance here. Yeah, you build a record of instances and then you can like pass that around, which is what Haskell does it implicitly for you. Okay, So, and actually I'm not so familiar with the implementation details of FPTS. So you saw me like struggle to explain the URI thing. But I did implement it for RemoteData already, so. But I did it in a different way. It was a RemoteData that the type E was fixed. Okay, so we have the F, right? But we don't have a data because the F came. So what we can do, but we do have a RD. So we have these. It's right here, down here. What we have, and then we have the F, which goes from A to B. So what can we do with, like, we have a function that goes from A to B, and we have the RemoteData A. So basically we can just functor map, right? Of A and F. And we don't need to wrap it in success. Expression. Oh, yes. Yeah. So this should work. So basically what we're doing, we have the F and we still have the A inside the RemoteData, so we can map with that F to return the remote data of B that we need. That's apply. Apply has also laws. Identity, which is the same thing as we saw. Homomorphism. That's common. Okay, so we map, but we preserve the structure. So what does homomorphism do? If you go if you put a function that goes from A to B inside, and then you apply that to an A, it's the same as just calling the function first and then put it inside. Okay. An interchange. We have a function from A to B, and we applied it to A. It's the same as putting the A to B. Okay. Yeah, functor map can be implemented in terms of applicative. Okay, I'm not gonna go too deep into these laws. But yeah, we implemented the apply. So now we have the app. And what's the cool thing about it is that so let me see if I can build the example. So we had a function that gets the name, right? Takes a user and returns the name. And we had the value and we can apply it, or if we have the user inside RemoteData, we can apply it inside the RemoteData. But what if we have a function that goes from user, and then text, but let's say A and B user as well, and it says something like, I don't know, let's say it or kill. Let's make it more fun. So A kills B. So if I have, and now we need to make another user arc. Okay. So now we can say that chain kills mark. Chain kills mark. But what happens if we have success of chain and success of mark? How do we get to, yeah. So here is what we can say. We can, yeah, we cannot do this, right? We saw it with Fonter already, when it cannot do this, doesn't work. But what we can do is we can put the kill inside the success, because if we remember here, the function was inside. And then we can say apply up to success chain, and then what is the type of f? Yeah, this is still needs to take the second user. So now we have the function, and we can up that one more time to success mark, and yeah, and now we get the string. So now we get something like success data chain mark. So, and this pattern works for function that takes any number of arguments. You just applied all of them. So basically the functor allows us to take a function that takes one argument and apply it inside our functor, and apply lets us take functions that takes a lot of arguments and apply them inside. And this was mind-blowing to learn for me. It took me a while learning Haskell, but it's really useful. And we'll get to, we have time, yes, I think we have. We'll get to a part where it becomes a bit easier. Okay, so now after we were in apply, there is only one load associative context. But then after apply comes applicative, and it just adds the off, which is kind of similar to this. So let's take applicative, and in Haskell this up and off are both in applicative. So this is so now we can just spread apply, and then we can implement off, which is basically success. Yeah, so it takes an A and put it inside. So now this could be, that could be applicative of that would be the same. Yes. Work. Okay. Should. Okay. Should run this just to show the examples, but no. So the next thing that comes is monad, the dreaded monad. No, comes chain first. Yes. So let's implement chain. Does chain implement? Chain implements chain and extends apply. Okay, so we can. And it extends apply, so it extends apply, not applicative, and it implements chain. What does chain do? And let's copy. So this is data. I'll fix that after. Chain, and this is basically all there is to monad. So what does chain do? It takes the error, the A and the B again. These are all the same kind of like very similar functions. It takes an F of A, so it's remote data of A. It's remote data of E and A. Then takes an F, but if you look at this F, it takes an A and it returns remote data of E of E. So that seems like a small difference, but it's quite a big difference. You can copy the fold, but in this case, there's just A here. Yeah. So A, we get the A, and so we have the A here, which is of type A, but we need to return remote data with the B. And how we can get remote data with the B? With, well, we can apply F. With F already returns remote data with it. So the difference here is that functor at the beginning, it couldn't change the structure, right? We saw that if we change the structure here and we say loading, we get these type checks, but it doesn't pass the laws. It doesn't fulfill the laws. Right? But here, that got formatted. Here F already returns the B, so we don't need to wrap it. If we do wrap it, we lose. We get the nested one. And what does that mean? Well, if we go to examples, now we have a function that takes, let's say, always exclaim, and exclaim for some reason takes the name, but it returns success with name. So if you see here, it returns data with error. It returns not just the name, but it returns the remote data inside. So if we do functor map of our chain, no, fetched user with exclaim, what is the type of this? So we have remote data and then inside another remote data. But if we do chain, we get the remote data because it flattens that for you. So it's kind of like what promise does in JavaScript. When you put a promise of a promise and you just get the one level. And that's all, almost all there is to monad. So now let's take a look at monad, because that was chain, but yeah. The monad type combines chain and applicative. Okay. So it's also monad. So now our instances, we have monad is 2 with, and then we can spread chain, spread. That should work. Yes. So that's basically more. And we implemented all of it. So we contour, applicative, and monad. Is there 5? Yes, there is. So we saw map, but we saw that map confounter works only on the right side, so on the success branch. But what if we want to transform the error as well? So for that there is typeclasses. I don't know what it takes. Let's see. Typeclasses implements by map and map left. Okay, so text theory and by map. What does by map do? It maps on the both sides. Let's just copy map. So it takes the error A and the okay. Takes F. Yeah, all data of EN. Okay, sorry. The F goes from b and g function. So a b. This returns remote data of E and P, but one second.
Tiny flames will dance across the darkness.
Sorry, I'm back. Okay. So, in the case of the success, we map with that function. In the case of the failure, map with this one. And for some reason, it doesn't type check. Declared but never read. What? There is an text error. Yes, there we go. You see, I don't know if it's here, but you see, this is the verbosity of types. So, but we still miss it map left. And map left should be easier because it jumps up. But on the left side. So from E to then the A is the same. Change. What the heck was that? That didn't sound like fireworks. I don't know if you heard that, but that was quite a Yeah, man, that didn't sound like fireworks. It shook the. I mean, not like a earthquake, but like I felt the shock. That was strong. What the heck happened? Man. Now I'm curious what happened and I'm worried as well. I hope nothing wrong with anybody. Whoa. Kind of want to go on. Oof. Okay, so this stays the same. This change. Yeah, so the failure is the one that we change now, and the success stays the same. So this is by conquer, and basically, so one example could be I have get name. Let's say error message. So now, in the same way we can do get error message with no error. Wrong, right? We can either by map left with user get error message, and now we get remote data of string. We map the left only, so the user stays the same. With bike font. Sorry. Yeah. Or we can map both. So first was the get. No, this one, the map left was first. So now this goes transform both types, and that's what you can use bike functor. I think, yeah. That's it. I wanted to implement some monoid, but let's take a look. The implementation either use other. So it implements quite more for either, but yeah, it's left, it's right. So these are all utilities around either, but what I want. Structures. Right. Pipables. Up left. So It implements all of these things, and then it passes them. Okay, so these are the stations. Okay. And then okay, so it creates the either with monad, foldable, traversable. Pipeable sequence, yes. Okay, there is no more. Okay, there used to be pipeable in the function module. Okay. Okay, so then we could state something like remote data is okay, so defines here Yuri to kind keep you counter applicative monad so by functor and oh, then it puts them here. So all data has, I think for now, monad and Python. So yeah, I guess that's it. So now we can use remote data like that. But he implements also pipeable. Non-pipeables are the ones we define, but then there is pipeables as well. And what does that mean? The function goes first. Okay, so pipe equals pipe. So this is functor, or we can say But what is the instead type? No, I'm for yes. Type. Okay, so what does it do? It takes first the function, then the remote data returns. So now function and remote data. So check what. Yeah. What's the reason of it? So there is pipe is here. So now let's just remote data that map is the pipe of version. Oh, what? So this implements all the pipeable things. Then what does it say? Does it mean that if I give it a function, it returns the pipeable function? Yeah, it's doing basically what I just did. I don't get it. We have the more data defined twice. Okay. I think this used to work in a previous version. I'm missing something, but yeah, let's see it. It's a problem. It's not that problem. Yes, problem is that. Yes. So now I have the pipe bubble. Fine. Takes the function first, and then the remote data A, and let's see what else we have in the instance. Map left by map change up first. So up first flatten, up second, and chain first we didn't implement, but we just like got them for free by implementing the other instance. And what is another type class that is interesting to implement is monad throw, I think. Okay, so let's try to implement monad throw. Okay, so monad throw is what does monad throw need? It needs throw error, and throw error needs to take. The 2 is for the kind. So in the case of remote data, it takes 2 type arguments. And yeah. So monad will be for example, for option, and then if you have 3 or 4. So monad throw takes, okay, so it takes an E and an A, the E, and it comes remote data, and I guess this is just failure. So we can just implement it as failure. It needs to be monad. Yes, so now we can put monad throw as well. And monad brings the monad throw. So now get from either and from option, flatten or else, from predicate. Those are all coming from free because we implemented monad throw. So that's a cool thing of typeclasses. Now what else? Well, we could implement foldable or another of those, but I think that's fine. That's monad IO. From IO. I don't think this is our case, because yeah, we don't want to run. I think that's it for today. It's almost... Oh, by the way, I think I should find a way to celebrate when the connection doesn't go down. I hope I'm not jinxing flashings in it now. Yeah, it didn't go down like last time. Yes. The last time I managed to connect before the Twitch finished it, because I think it gives you 90 seconds, but I don't know what's wrong with this. But not today, so there are other things that we could implement. So for example, monoid C option. Option has a monoid. So apply. Please apply monoid. Okay, it like applies a monoid that is inside. So you could use a monoid for numbers. Okay. But basically it's a semi-group and then monoid. But then there is first. Yeah, so this will be interesting. It gives you the first that is not none. Let's implement this one. So
I'm about to do something, scared of the outcome. I'm sorry to say this, but you aren't good for me. I'm about to change it all.
there is no. So monoid is of kind type or kind star. So there is only monoid, and then this will be called, let's say, get first monoid, and it takes E and A. And it returns monoid or remote data of B and A. So what does monoid need? Monoid needs to be a semi-group, and to be a semi-group need to be magma for some reason, and magma has a concat. So I guess we can do cat semi-group first. So monoid. So semi-group, we need to concat between A, which is the node data of E. We don't need the E. No, we do the E. B, which is also remote data of E and A. And what do we do? So in the case of failure, case of loading, so for option, how did it work? If both are none, gives you none. If one is some, it gives you that one. If the other one is sum, it gives you that one, and if both are sum, it gives you the first one. So how would it work here? It's loading, gives you the B. I guess. It's success. Get the data. Return success. On with a. But I'm not sure, because in here, if this basically you get the second probably what you want is something like B tag success, and I return the B, otherwise I return the A. Yeah, something like that. And first monoid. Get first semigroup. That concat. And empty, which will be not us. So monoid just adds the empty, sorry. And why do we need the get thing? Couldn't it work? Because we are not doing anything with the data, so couldn't we work? But the problem is we want, for example, mono first number, where we do get monoid first. Yeah, get monoid first, and we say this works for errors and numbers. And it's basically only, this is a monoid of RemoteData, it's only for type inference that we do it. And then monoid first number, we can do concat of, oh, it was user. But this, for example, bottom in the examples section. This will be success chain, and then put the coding here. This is also success chain, but then if we have success mark, and this is also success mark. Let's put it like this, mark and mark. So in this case it's success mark because it's the first success, otherwise. Okay, I went over like a few minutes, it was supposed to finish, but this is for all the other types of type classes. internet then. I think I will publish these. So yeah, thank you for joining, and let me what we want first. Yeah, so I'm missing the test with fast check, but for the next sprint, I'm already back to work. Come on. So again, join the Discord if you want. We can chat there, and there are other streamers and there are notifications when we go live. Go for it. So, I was live today and I got okay, so for the next sprint is sprint faster. I was going to start the book day section and shared about and do this book. Yeah, parallel and concurrent programming in Haskell. I'm still going to do that, but that comes for the next for later. So now basically we'll go through with someone from the FP chat. We'll go through some of the chapters of the functional Haskell programming from first-person principles. I read until the Monad chapter. We'll review a few chapters with them, and then I think from chapter 14. So that will be on Tuesday. So yeah, looking forward to have someone on the stream and do something together. So yeah, again, thank you for joining. That's it for today.